Welcome to Kernel of Knowledge. In this video, we're going to take a look at latency and throughput. These are terms that you may have heard before, but maybe you're not that confident with them. By the end of this video, you'll know exactly what latency and throughput are, as well as how to use them in system design interviews, while also understanding how you can optimize for throughput and latency within your designs. Let's start with throughput. So you can define throughput as the amount of data or number of operations that a system can process per a unit of time. So this might be the number of tasks, the number of API requests, or the number of operations that your system can handle per second. A good way to think about this would be if you've got a factory and a conveyor belt churning out products. The number of products that your conveyor belt can churn out per minute would be the throughput of your factory. The same applies to an API. The number of requests it can handle per second would be its throughput. In terms of measuring throughput, if you've got an API client, you would measure the client to server requests as requests per second, or maybe database requests, you would measure them as transactions per second or transactions per minute, depending on the use case. If you want to increase your throughput and optimize your system, you can do things like horizontal scaling through adding more servers. You can do vertical scaling by adding more CPU and increasing your resources, or you can make your systems more efficient. There's also other things you can do like parallel processing, queue management, or batching operations if that's appropriate for your system. Let's take a look at latency now. So you can define latency as the time it takes for data to pass from one point on a network to another. So this would be the time it takes for a client to make a request to a server. That would be the latency. In terms of measuring latency, obviously the lower the number, so the smaller amount of time it takes, the better. Increased latency is generally always a bad thing. If you ever played video games, you'll see sort of the ping. The higher ping means it's a higher latency, and that generally results in bad things like game lag and just a poor experience. In terms of measuring latency, you measure it in time. You probably have seen online and in various system design, newsletters, etc., latency numbers that every engineer should know. And while you don't need to know these off by heart, it's important to understand the scaling impact of each of those. So if we look at an operation like one CPU cycle, that may take 0.3 nanoseconds. If we scale that up into a more understandable time, let's say it takes 1 second. If you then look at something like reading and writing from a solid state disk or an SSD, that may take 50 to 150 microseconds. If you scale that up, it could take from 2 to 6 days. Equally, if you to do a rotational disk or a hard disk drive, that can take anywhere from 1 to 10 milliseconds. Again, if we scale that up, that can be 1 to 12 months. Then if you look at a request from San Francisco to London over the internet, that can take as long as 183 milliseconds. And if you think of that scaled up, that could take 8 years. So the important thing here isn't to know the exact numbers, it's to understand the scale of each operation. So you can see, for example, if you look at the internet one, taking the request from San Francisco to London, you now understand perhaps why having a CDN or resources in London is a super important thing. You don't want your request taking 8 years in terms of scaled up time. In terms of how do you reduce latency? Well, as I said, there's things like CDNs, there's caching, there is reducing network hops. So by having servers located in the geographical region that you actually need, reducing requests between microservices, and of course, there's always code optimization. So comparing throughput versus latency. With throughput, higher numbers are better. You want to have more amount of tasks in your system. You want to do a more amount of work per a unit of time. With latency, lower is better. You want a task going from a client to a server, start to an end, to be as quick as possible. So when do you want to measure latency or throughput? Well, for latency, it's really crucial for systems where response time is critical. So this might be real-time applications like gaming applications, user interactions, or basically any time a user is sat there waiting. That may be from a network request or when they've clicked a button on your website. For throughput, It's the amount of work in a time period. So this might be your server handling a large number of requests. It may be batch processing or maybe data pipelines. Ultimately, when you want to measure latency or throughput really depends on your system and what you're actually optimizing for and wanting to measure. So for a low latency system like an online gaming server, latency really is the thing you want to measure here, and throughput wouldn't be particularly useful. You want low latency to give your users a great performance. You don't want to have lag or to be stuck waiting for things to happen in a gaming situation. For a high throughput system, this would be something like a payment processing system. If you think of payment processors like Visa and MasterCard, they need to handle a huge amount of throughput, and only being able to handle, say, 1,000 transactions per second just wouldn't work for payment processing. You need to handle millions of transactions per second. Thanks for watching. If you found this video helpful, please do subscribe as it really helps out the channel.